Let's see. Um, so in lab 1, some of you have submitted the topology part B, right? For the business, and this is an example of a student work that I had pulled from the Mondays class. And I wanted to highlight some of the things because some of you might be doing this later. And this is important in the security portion of the job, because sometimes you will have to work with engineers, right? Network engineers to figure out like what's the flaw in the network, how we can redesign the network and be able to improve the security area. So part B for lab 1, it requires that we connect the workstations to the switches and the routers along with the phone and all the systems for the small business. So in this diagram, you can see that this individual had set up the PC to the switch. So that's correct, right? So you want the PC and you would connect this using the Ethernet cable, right, to this particular switch. Now from that switch, we're also going to connect the printers and the phone. And logically and physically, this is done correctly because assuming that the person who sits at this PC would need to make phone calls, maybe for the business purposes, along with maybe print documents like invoices or statements for the business, right? So that's correct. So you would see that we would need a switch that is going to accommodate all of these devices. And then the student had add another switch here, right? And to be able to connect the copier and also an additional hub. So the difference between this hub and the switch here is the hub is unmanaged, right? It doesn't give you liability or reliability in communication. So what I would also recommend is to replace that with a smaller unmanaged switch, right? Using a hub is okay. And then we would bridge the switch with another switch using a crossover Ethernet cable. Okay. Now the server sitting at the top right here, okay, is okay. It's not ideal. Okay. As you know, that most routers don't have a lot of ports connection. You want to stay away from putting major appliances and system to your router except for your switches. Okay, on the rack, you're gonna see the router and the uplink switch and some of the main switches. Okay, and that's in the server closet or the main closet where we manage our system. So in this case, they're using a wireless router. Ideal or not ideal, that's really up to the business. Normally, you would see a regular router there. And the switches are connecting to the router using Ethernet cable. So the switches are inside the network and everything that's leaving the network is here. Now the server placement, I see a lot of diagram with the server placement here. I don't recommend that for a security reason because if they can get to your router, they will get to your server, depending on the type of server you're using. So if you're placing the server here, that would be for like proxy server, or that server is functioning like another router is a gateway. It's like having two gates, right? Your router is a gateway and there's another gateway. Sometimes they do that, right? But it's redundant. So I would take that server, right? And I would connect it to one of the switches, either this one, or you can add another switch and add the server to it, which is more ideal. Now, the security part comes in is where we would need to add security appliances within, right? Like network intrusion detection system. So to correct this or to improve this topology, you would take this switch, connecting with this switch, and then that line is then going to be connected to the router. Okay, it's okay this way, but I would remove the server right here and add it to the switch on the left or the switch on the right. Okay, the server cannot be at the router for security reasons, and the functionality is not ideal. Okay, so that way when we need to add more server, we'll just add it to the switch instead of, the router is going to run out of ports. Ultimately, routers don't have that many LAN connection, and that's important to think about. Okay, so I want to show you one more. So this one was also submitted in the Monday class, right? Let me see if I can zoom in. So you have your smart devices connecting, right? But the on the diagram, this router here is not a wireless router. Okay. You saw earlier that they chose the shape that's appropriate. So on this diagram, the router here is a regular router. A regular router, you're going to see in the later weeks that you're not going to have that many physical Ethernet connection to it. And it will not have wireless adapter to recognize those devices. So if you're using wireless router, make sure you have the appropriate shape. But let's say that this is a wireless router, right? See how they have the two switches here? So you have a switch here and a switch here. That's bridge. That's correct. And then we're going to connect those switches to the main router, right? And that comes out to the internet. So this is correct. Okay, right here. Now, see how there's a server connecting to a switch? So that's also correct. And you would have your PC connecting to either switches. The only improvement for this is I would treat this as a regular router, and I would take an access point and I would connect the access point to one of the switches and then connect the wireless devices to that access point. So I can add another access point over here or over here, right? And I would be able to connect the mobile devices to that access point. So I would recommend that. But ultimately, when you bridging the switches together here, if I sit at this PC on the left, I should be able to print using the printer on the right, right? That's the goal, is to be able to interconnect internally so that way if I'm here on this segment, I will be able to do that. And we can configure that through IP addressing and a lot of other things, okay? So that kind of give you a little bit perspective because I've given you the tasks, right, without giving you too much of an example. I kind of wanted to see how you grasp the information and be able to do that. So look back at your diagram and you can think about how you would improve, because if you do go for the bachelor degree, you are going to have a class that's going to require you to either take an existing network diagram, implement security solution to it, because that's what we do, right? By adding devices, by, specifying like logically how the data is going to flow securely, right? So from a security standpoint, we need firewall and additional appliances in different area. And if you take CIS27, it really addressed that, right? So you would need to add intrusion detection system on this segment and this segment. We need to place a border firewall over there, right, at the edge of the router. And then there would be other things that we would add. Okay. All right. So that kind of give you a little bit of example, so you can go back and take a look. But everybody got full credit for attempt in my book. Okay. So in this week, we're going to break down a little bit more on network components. I think a lot of this is reviewed from CIS25. However, because this is a networking class, we're going to focus on network devices. We are going to configure network adapter today. So you would see that your network interface card now on the server, you're going to see like this. This is a screen. This is an image for a server board. You're going to see multiple NIC. And when we configure, we normally, the OS or the software would allow us to do a NIC teaming, because as you know, server's gonna receive a lot of requests and it's gonna respond to a lot of requests. So if you are relying on one Ethernet connection, you are gonna have a bottleneck, which is it's gonna slow down everything there. It's kind of like 5 lanes merging into one. So you want to have a system, right, that's responding to requests that would have multiple network adapter. And you can always add in also a separate component using a bus like PCI Express, right, for your adapter. Okay. And then the second one, you would see that this is a transceiver. It looks kind of like your network adapter. Transceivers is old. You're gonna see that they are often with coaxial. You do find some adapters that's still being sold. So basically, this you can sometimes have a motherboard that has transceiver that's like older motherboard. You do have an option to be able to buy an adapter that would integrate transceivers, or sometime built in with the network adapter, as it's shown here. So if you buy, so often you would see transceiver looking like this. So I was in San Jose on Wednesday and I was there for the AI infrastructure. All the communication company and all the big tech company were there, right? That's their show to be able to sell to people. Broadcom was there and they were talking about this. They were talking about like Ethernet standard. They were talking about how switches, right, have processor that's able to provide throughput at terabyte for AI systems. So so a lot of the images that were on the presentation, I was like, oh, there's the transceiver, right? There's the adapter. So you would see something like this for SPF, and often you would see this is for network appliances, your switches, your routers. You would see something like this. And then you can also buy, it looks like an adapter where you would be able to connect with like either a male or a female pins, right, to the system. So some of these are you're gonna see that's a little older, right? And the benefit of doing this, and it talks about this right here, is that you can attach it to a certain appliance externally. So you don't have to open the system up and install it. You can just adapt to it, right? It has an adapter portion. So your modern transceiver, you often see that is pluggable. So like the SFP up here, it's like this. So you just slide it in. And you would have like different rate of transfer depending on the type that you see. Like the QSFP, you would see that it's 4 times, right? And the newer transceiver now, the one that I saw at the convention, it's tremendously faster, right? For AI systems, you at the data center that they use for AI, you have to have quick throughput in order for it to pull and analyze your data. So we see communication differently now that we have AI integration. So what you see is you see the rates for those transceivers and those appliances is, in the terabyte area. And they are higher in price for sure. But they were saying that ultimately at the data center within the network on the rack, you still use Ethernet cable and Ethernet adapter, which is what we are mostly relying on still, right? Okay, so let's go through and answer some questions, and you can find a lot of these answers on the notes. You can summarize them. You can also go in and copy and paste. You can look through. But the functionality of the network adapter, ultimately to summarize it, is to be able to get your data, right? To transfer your data from your system into the network. So it says that is preparing your data, and it's a way to transport your data. And as you make the Ethernet cable, you would see that it sends it through each of the copper wire, right? And it sends it through the bus, which is where your adapter is connected on the motherboard, right? Well, if it's on board, there's a bus. So a bus is a pathway where the data travels. So on your motherboard, there are many buses. It's kind of like how there are many roads in a in a home, right? I'm not home, in a town where you would be able to get from point A to point B. So a box is like one of those roads. We want to be able to transmit data from one system to the next, but it has to travel through. Sorry, it has to travel through. My system just decided to take a break for the projection. There it is. Okay. It has to travel through these buses to be able to send the signal. Everything that you see, right, in the computing system, when it transmits, it is an electrical signal, right? Because your computer is an integrated circuit, right? It is IC. It basically is made of all integrated circuits and be able to send the electrical signal. So when you send data, it's going to send it through the copper wire one by one, bits by bits, right? And that is at the physical layer. We talked about that last week. Now, the difference between the transceiver that is built into the system, which is called onboard, right? If you have a transceiver that's on the motherboard, right, that's called an onboard. And you see that on some of the older computers, older system. Or compare that to an external transceiver. You saw that we can plug it in, right? Externally, it's kind of like you can adapt to it through another connection or another port. So onboard transceivers are built onto the network interface card. So your network interface card already have a transceiver built in. Now, the external transceiver is an actual device that we would connect to the adapter, right? So it is a connecting device that you see, and you buy that as a separate component to be able to connect. So the benefit of using that is that you're able to adapt it to a router or switch, right? So if I have a switch that doesn't have a transceiver, I can buy an external transceiver to be able to connect to it. And then you would be able to use it. So it has the pluggable capability, so that way I can adapt to different network appliances in my network. Whereas if you have an onboard, right, it's only going to be integrated for that network adapter. So if that network adapter doesn't have it, I am going to be required to buy an external transceiver. Any question? So as you go through and you prepare for the certification, a big chunk of your certification is going to focus on network troubleshooting, right? And part of network troubleshooting is to really look at whether we receive communication on our system through the network interface card. So if someone tells you that they're unable to connect to the internet, likely that maybe their network adapter is not receiving signal or configured properly, or they're not getting an IP address in the network. So we want to make sure, right, that when we're troubleshooting the network adapter that's using a lot of different connectors, we need to make sure that it is on auto mode. This mode allows it to see, right, that there are many connectors and it can change, right, up to the appropriate connector as needed. And we're not just talking about the PC, we're actually thinking about the network adapter on the server, right, the network adapter that is used in the appliances like switches and routers. So we want to make sure that we configure it as auto, right? We can set this. And I think by default, out of the box, it's already on auto, but in the case that if it's switched to a specific connector, and if that connector doesn't receive signal, then you just need to go back and change that to auto mode so that way you can see this. Okay, any questions? Okay, so where can I find this information? All your transceiver information is from the previous page going into, so 2, 3, and then the troubleshooting is on top of page 3. You can find that all the steps. So it talks about auto mode right here, right? Making sure that you change that on the setting. And so now we're going to talk about NIC transmission methods, which is the next question. So in the last week, I think you saw some of this coming up, and we're gonna repeat this throughout the semester. You're gonna see more of the transmission methods or types repeatedly, right? In all communication systems, these are the methods that is accommodated by the system. So simplex. This allows communication to be one direction only. That means that some system can only send, right? When you turn on your car radio today, you know that it is only sending. Okay? So it allows the communication to be one direction. And some system would only receive, right? It cannot go both ways. So that is considered to be a simplex system. Now, you would see that some network communication system, it's only going to be able to send. It's basically broadcast to everybody, and it's going to say, hey, this is the information about the network, right? Or some system that it would only receive, and then, it's only receive. It's able to only receive information. Now, if we use technology like that, right, it cannot do it at the same time, send or receive, send and receive. It has to be only send, right, one direction. It cannot be both. Now, half duplex, it can either send or receive. It cannot do two together. So if I use a half duplex system, I can set it to send, or I can set it to receive, right? And most systems allow you to accommodate all of these, okay, today, okay? Some, you open the box, and sometimes, most of the time, we are gonna rely on full duplex because it's back and forth communication. But sometimes you only want a system to function a certain way, so you can set it to be a certain mode, a certain method to send. So half duplex means that it can do either or. It can send or receive, okay, but it cannot do both. So when you set your network adapter to only half duplex, it's going to only send or receive, right? But if we want to, by default, our network adapter is full duplex. You receive signal and you can send signal. That's how we're able to transfer data. You can submit, right? You can visit a website where it actually sends the request outbound. And then when you load the website, it's receiving signal back from the domain, from the web server. So your system, when you transmit data, right, and you receive data, it is a full duplex. It's able to do both at the same time. So if your network adapter support full duplex, which it does now, right, you're able to receive data in the 4 pair of wires as you do the Ethernet, you see, right? The signal is then being sent through the copper wire. You did the twisted pair, you untwist and you arrange them, right? And if you did them correctly, you're going to be able to receive them through the wires represented with the 4 pair, okay? This is going to give you the highest throughput, the fastest transfer rate for the capability of your network adapter. Okay? So for the quiz, the final exam, and the certification, make sure we know simplex, half duplex, and full duplex. Guaranteed that these things will pop up on your quiz, and the final right? And it will likely pop up on your certification exam. So make sure that we distinguish between these three. Any question? Okay, next we're going to talk about how we would be able to determine, right, who manufacture your network adapter. When you buy a laptop or when you buy even a gaming system, the motherboard maybe, let's say that you bought an MSI motherboard or a Gigabyte motherboard. I saw them at the show on Wednesday. They were giving away some pretty cool things too. So you might think that, oh, Gigabyte created this network adapter, but likely it's not, right? So when you buy motherboard, if you have a network adapter that's built in, a lot of the times they contract that out to another company, perhaps somewhere in China, right? And even if you buy a Dell system or an HP or an Alienware, right, the adapter itself is actually made by a different company. So how can you determine where did that adapter come from? Who made it, right? This is important for security people because we sometimes have to pinpoint which system that is, who that is that's entering our network, right? Or actually attempt attacks. And the way that we would go back is we would look at the MAC address, which is the media access controller address, the physical address of that adapter, and we would use a tool to find the information. So all vendor, all manufacturer are given a list of MAC address, registered MAC address, okay? And they would use that to be able to ingrain or program in the MAC address for each of the network adapters that they sell, whether it is an onboard adapter or a separate adapter external that you can adapt in, like a peripheral device. So, and even the wireless adapter that you see, so first you're going to locate the MAC address. Okay, so how can I locate a MAC address on Windows PC? Yeah, does anyone know? Yeah, so you want to be able to go to CMD, right? Open that up. And you can do ipconfig /all like this. It's going to give you everything, right? There's another way, like I think on some of the command line, it doesn't command prompt depending on the system. You can also use getMAC command, but if you do this, right, if you go down, it's going to give you the physical address, which is right here. Okay. Now you're going to take those values and then you're going to plug it into the website. That's what's shown on, right? So it talks about the MAC address here, and I'm going to break it down a little bit more. So I put a link for you to look at. There's IP check tool and there's Wireshark OUI lookup tool. There are other websites that you can use. So you just take your MAC address and you plug it into the website and it will tell you, right, who created that adapter. Okay, so you can try that for your system at home. And sometimes the website uses a colon as a separator, not a dash. So you just got to make sure that you type in the right format. So MAC address sometimes is represented like this with the colon, right? Or sometimes it represented with the dash like this, okay? So they are hexadecimal character, right? That's a base 16 number. So I teach discrete structure and assembly, and I have to go over the number system and number conversion for computer science students because they work with different encoding systems and a lot of different things. So if you have taken 7 with me or you're currently in that, you probably see that, right? But in networking and security, we deal with these numbers all the time. So the hex value that you see, right? It will be 0 through 9, A through F, and it's represented your address, right? Are we gonna be running out of MAC address in the future? Likely. And then we would have a different way to represent a MAC address. So a MAC address is like a physical home address to that home, that house, right? But the IP address can be represented as maybe the fourth house on the street, right? So it would be temporary. We can use IP address as a temporary value to pinpoint that system. It can also be permanent if you statically assigned it for the network, but the MAC address physically is ingrained onto that adapter, right? So when you look at the first 3 bytes of the MAC address, that's going to tell you the vendor information. So when they program this into your network adapter, the first 3 bytes, it really is the unique ID that is used for Dell, right? That is used for a company that created that network adapter. Okay, so that's how you can find it. Okay. Now in security, why is this important? Well, sometimes you have to follow that system, right? So let's say that an attacker got into your network and you have to find where they go, right? All your switches record that MAC address. So if I connect to the network via the router, like the wireless router, I want to enter the network and find all the databases, all the server. But in order to do that, I have to travel down that road, right? I have to go through the switches. So the switch table is going to record all the MAC address of all the connected system. So you have to find that system by its MAC address. And sometimes, the LAN IP, the private IP. So having understanding of the MAC address is important. Okay, so you can find a little bit more information about that, bless you. And then, so it tells you to locate the MAC address and use your OUI tool, right, to look up the organization that creates the MAC address. And you can find more tools available online. Okay, I'm going to move 5 down to the next one. Okay, so what's the set of troubleshooting in it? When you interview for a apprenticeship job or IT job, if let's say you're applying for level 1 network technician, likely that they're going to ask you how do you troubleshoot a system. They want to see how you responding to a ticket that comes through, like if you're doing tech support, or how do you fix a system in the case that you're given a broken system, right? A system that's not connected to the network, right? We are in the business of fixing things, right? We are the firefighter of the IT world, so you have to be able to understand how to fix these things, right? So how do I troubleshoot a network adapter? First, you need to check the physical connection. Always look at the cable, right? Is it connected to the adapter itself, right? In the back of your computer or on the appliance, okay? Check your cable connection to your Ethernet card. The important things, look at the LED, right? The LED is going to tell you whether it's receiving signal or not. Is it amber or green? Right? And this is the typical troubleshoot. The typical things that you also do when you're troubleshooting your wireless router at home, and so look at the link light to verify if there's physical connection. If there's no light, then maybe that's a bad cable, right? Or maybe that's a bad adapter, okay? I always check the cable first, likely that you're gonna have a bulk cable more than the adapter, okay? So, and then you can make a quick cable, now you know how to do that. Then after the hardware level, so when you troubleshoot, start with the hardware level first, then we're gonna move to the software level now. Right? So once we check the physical system and the light, if it's there, then we're going to move into the configuration. So we're going to check to see if there's an IP address. Okay. I always like to reboot system so that way it refreshes, right? In the process. So if you already checked that, restart the system and then check to see if an IP address. How do I do that on the Windows system? I would go to command prompt, do IP config and see if it's obtaining an IP address, right? Now, if it's giving you, and we'll talk about a typical address, like a default address that's not part of the network, or if it's not giving you any address, it says that Ethernet adapter is disconnected, then we would then need to go back and check power adapter. Okay. But if you already checked the physical connection, we want to get an IP address. And then you can ping the address. So the way that we check to see if our system is talking is to send it request and see if it's responding. Pinging is a way that we can see if our system is responding to requests, right? So we can ping ourselves. So this is a loopback address, and the 127.0.0.1, it's basically is asking itself if it's connecting. It's a boomerang address, as I call it. So what it does is it sends a request to itself. It says, am I connected? And in Windows system, it's going to send 4 requests. And if it's successful, it's going to have 4 successful response. So I'm going to show you how that's done. So in command prompt, you simply ping your own IP address, or you can do a ping 127.0.0.1. You can try this on your computer, right? See how it's sending and it's receiving reply, right? So reply first time, second time, third time, and fourth time. So it's successful. And it tells you sent 4, received 4, 100%. That means that that system is talking. It's connected, right? Now, if you look at the statistic, if it's timing out right here, that means that the system is not communicating, right? That goes back to your adapter, your cable, and the network, the IP. Okay. So there could be disconnected physical components or misconfiguration. Those are 2 things. Now, in Linux, if you're using Linux system, you do IP space address to obtain the address, and you do ping command the same. So you do ping, and then you can do a loopback address. The 2127 is called a loopback address, or you can do its own IP address. Okay. All right. So we now know how to do that. Okay, so we talk about ping. We can run the diagnostic program. I think Microsoft has its diagnostic program. It's going to go through and test. So in the back, it's basically testing the same thing you're testing. It's going to try to send requests and see. It's going to check your configuration. Sometimes this helps, sometimes it doesn't, but at the software level, we can do this, right? So check your hardware, then check your software. And that's basically the rule for most of the things we troubleshoot with computing. All right. Now, once in a while, right? Or if the first time that you install a network adapter, you need to update the driver. That's very important that you do, and we update things for security reasons as well. So a driver is basically it's program that contains instruction for the device to function, right? It's kind of like the device needs to be taught what to do, right? They program that below the function. Yeah, so from the manufacturer, right? Ideally, but let's say that you have a laptop, right? You might not know who created that adapter, right? You don't want to go to the extent of looking that up. You want to go to the laptop manufacturer, HP, Dell, whoever created your laptop, and you put in the model and it will have all the driver. Usually on board devices, it comes with a group of software, right? And then you just need to install that group of software off the bat. Now you can update things individually. Microsoft has default generic driver, right? Is that good comparable to something from another company, your manufacturer? Well, depends. If you are using that device with all the features, ideally you should get it from the manufacturer. Okay. But if you're using it just for the basic functionality, a lot of times most people would use the generic Microsoft drivers. That is, So if you tell Microsoft that I'm updating driver, I'm just gonna let it go out and find it. It's gonna look in its library, the DLL that you have, when you update and install Windows, it has a generic library that you use. Okay, so it's gonna pull the driver from there. It doesn't necessarily go out to the manufacturer and do that, so you have to do that manually. Okay, so we're gonna open up Device Manager and we can click on Adapter. You guys don't have the privilege to do this on your system that you're sitting at, but at home you can. So I can search for Device Manager, right? Everything is searchable. We're gonna open that up. This allows us to look at the configuration for all our hardware, right? And so here's my network adapter here. Okay. You notice that I have a list, and all systems should, right? Your wireless adapter, if you have it. And on my system, I don't have a LAN port, so you don't see that. But you would see an Ethernet if you have a LAN port. So let's say that I want to update my wireless adapter. See the LAN card here? I just right click it, right? And I choose update driver, and it's that simple for Windows. So on interview, they might ask you that if you're applying for a networking job, right? How do you update drivers for your network adapter? You say easy. Go to Device Manager. You can search for that on Windows search bar. Go click on the adapter, right click it, and choose update driver. And there you go, right? If you have the administrator or the privilege to do that, you should. If you're a regular user, you might not be able to do that. So you have to have the privilege to be able to do that. Okay. Okay. So we see how to do that. So you need to know the steps, right? In case you need to answer these questions or do it yourself, right? So you just need to right click that in your device manager. Okay, before we answer number 8, let's go back to the notes and kind of so driver information, you can find it on page 5 of your notes, and it talks about how you're updating the driver there, right? Device manager. And then now we're going to go to the hub and repeater. And I showed you one of the diagram that using a hub, right? And compare that to a switch. What is it going to look like? So a hub looks like a small switch. Usually hub is not as smart, right? All that does is it basically pass or transmit signal back and forth for system, right? It doesn't know in case if there's an error. That's the main difference. So you would see a hub like this, right? And then you often would see sometime that they would bridge them together or connect them together, and they call that cascading. Back in the day, that's how we're able to branch out our networks, is because we have limited appliances, or sometimes we have limited ports to our appliances. So we'll be able to span out, right? Like if I want to add more computers to my network, I would need to cascade my hub, connecting one hub with another hub, and basically you're daisy chaining them. And the downside of that is you will likely have some error, and you will likely have some bottleneck issue down the line. But they talk about that here. So basically you're connecting one hub with another hub, and you would cascade that down until you have multiple, right, hubs, and you would be able to expand your network this way. Okay. And you would see that there are 2 options for the hub. One is a passive hub, and 2 is an active hub. They're different, right? Active hubs is an amplifier. It amplifies the signal before it sends it. The reason why they made this is so that way the signal doesn't degrade, right? Remember that you're going from one to the next one to the next one, and likely that your signal from the original signal is going to then degrade when you get to the fourth one on the cascade. Okay, so you would see that now on the passive hub, it doesn't have that capability. It doesn't have the amplification. Okay, so if you're using a passive hub, likely that your signal is going to then degrade, right? And you're going to get less signal when you get down the cascade. Okay, so amplification for the active hub. And then it also built in with repeaters. So what's the difference between amplification and repeating? So if it's repeating, it's going to take that same exact signal, right, and replicate it throughout, right? The amplification is going to increase the power for that signal. It's like turning on the volume in your car, right, radio. When it does that, it increases the power so that way when it gets down the line, it doesn't lose signal. Understand? So if it has a repeater and an amplifier, this is what you see with a lot of the wireless router now, that it's able to take your signal, amplify it so that way you get really strong signal, right? And then if you go really far with it, it's going to repeat. So the repeater's job is just to get it to the distance, and the amplifier is to get full strength signal, right? So you want devices so it can go up to 100 meters, which is what you see with Ethernet standard. It's approximately 125 meters, but that's the whole point, was to build that for the standard that we're working with, right? So it does that with multiple ports, okay? And then you have a bridge. So whenever that we're saying a bridge, it just means that we're taking two appliances and we connect them together, building a bridge across. Okay, so if I have a switch, I take it and I connect it to another switch, you have a bridge. I have a hub connected to another hub, but on the hub, they do a cascading, so you have to connect it from one port to the ending port, so that way it takes that, it repeats it to the next one and the next one, kind of like stepping stairs, right? You go from the top to the next one and the next one and so on. So the hub, when you connect that, is a little different, but the bridge, we can connect that. And like I mentioned, right, you're using Ethernet cable, making sure that it's crossover when you're bridging appliances, okay? Not the straight through, the regular Ethernet cable. It's standard A and B. Okay, so let's answer A. How do you connect three hubs that consists of, let me remove the S, that consists of 8 ports? Okay, so what I want is I want 24 ports for my network segment. And I have those small 8 hubs, the tiny ones, right? And those are the appliances that I'm going to work with. So you're going to connect an uplink port. So on the hub itself, there's going to be a port that specifically is for uplink. Usually it's labeled. And you're going to connect the port A to the first hub, any port on the second, and then use port A on the second hub to uplink it. So port A, the last port on the hub, it's going to be dedicated to be uplinking, right? So that's how we're going to take the last port on the first hub. We're going to connect it just like the last port. We're going to go to the next step, which is the second hub. We can connect it to any other port like port. I normally go last to first, so that way I can easily troubleshoot, right? If you start plugging it in everywhere and you have a mix, like one is like this and the other, you're gonna have a hard time. So schematically, we have to be logical about how we connect, so that way it's easier to fix, right? Ultimately, you want to think about maintenance, right, and troubleshooting. So we're gonna go from last to first on the second one, the first on the second one, and last on the first, right? And then from the second to the third, we're gonna go the last on the second to first on the third. But you can do any ports, like I said. I normally do last to first. It's just easy. Question? Okay, we talked about passive and active hubs. Passive contains no power source for electrical components. no signal processing, no amplification, so no regeneration or repeating. So you don't have much of a repeater on the passive hub or the amplifier. Passive hub or active hub has those. It has built-in repeaters and amplifier. So that means that the active hub requires more power consumption. And the purpose of a repeater, I mentioned that, so it basically takes that and regenerates it. It duplicates the signal as it passes it down. Sometimes some of them rebuild the signal. So in the case that if you have signal that degradation, which is lose of signal, it does rebuild it. Because the whole point is if I have, like, for example, a bit that's 1, I want that 1 to be intact, right? So I want to make sure that that signal is intact. So it's able to regenerate the signal, duplicates it and sends it down, or rebuild it and send it down. And like I mentioned, the repeater, its job is to get it to farther distance. So most of your access point across the campus or in a large area, they are built with repeater. So basically they are repeaters. And then we want to place it before the maximum distance. So if we have limitation with 100 meters, you want not to reach 100 meters because then you're gonna have degrade of signal, right? Before it can repeat. So you want to go a little bit before that, maybe 90 meters or 80 meters. It also depends on your physical geographical location, right? So we want to make sure that before the maximum distance, we put another repeater. And we do this for a lot of wireless signal. Okay, so we talked about bridging earlier. What type of addresses are used by, this grammatical error, are used by the bridge to determine the network segment of the destination system? And how does it use this address to filter the system connection? So internally, we are using MAC address, as I mentioned, because most of the things are the appliance that mostly handle the transmission is the switch or the hub, right? That uses a MAC address. So your physical address is used by the bridge, which are like switch to a switch, and it's going to determine, right? Earlier you saw students topology. You see that there's 2 switch on the topology. Let's say switch A and switch B, right? So let's say that I am using the PC on the switch A, but I want to print on the switch B because the printer is connecting there, right? So what it does is it's going to look at, right, the printer address on switch B, and it's going to get my request when I send print. It's going to go from switch A, go through the bridge channel, which is the line, go to switch B, and because of the MAC address, it's going to find the printer and it's going to allow me to print. So always know that it uses the physical address to determine where you are in the network, right? The router only gets you to the exit, right? The switch gets you to the street that you live on. So that means that it needs to get a MAC address. It's going to say, oh, that's a computer from this segment from switch A that's talking to the printer on segment B, right? Now and later on we'll talk about like IP address of how and how we use route internally to separate certain part of the network. So the address is then stored on the table. Where does this table go? RAM on the of the appliance, right? And which is used to locate which part of the network that you're sitting in or you're using. Okay. Now, from a security standpoint, can I go and modify this table? Sure, right? So if once they're inside the network, right, the way that they can get through the network is to falsify that address on the table so that way it goes undetected. Because network intrusion detection system, if you are MAC filtering, so the people who are doing the security, they basically create a list of what's allowable MAC address inside that network. It's called MAC filter. Okay. Now, if you're not doing MAC filter, then you're not doing security. So, in order to get through your network, an attacker, once they're inside, once they pass through your firewall and router, they have to take on a MAC address that is allowed inside. So they have to spoof it, right? Because your appliance is gonna go back here, it's gonna look at the table, it's gonna say, oh, who is this system? It's not on my list. Let's not allow it to connect, right? The logical port's gonna disconnect. So, but if they take on a real address that is allowed, then they're able to get from segment to segment. So attacking a network and getting through a network takes a lot of investigation and time, right? So when you do ethical hacking, you're gonna have to think about this, right? When you're managing a network, you have to think about this, right? So the switch table contains the systems are connected. And when we MAC filter, if we rely on the table to make sure that it blocks allow and deny. We can have an external appliance that checks the switch to do that, right? You can use it that way. Any question? Okay, let's take 11 down. I'm trying to get through this so you also have time to do your lab. It's a long assignment today, so. Okay, why should we use a switch to connect the system and devices instead of a hub, right? The benefit is that the switch provides security since your transmission is not sent to every port. So the hub, it like sends it to everybody. And that can create like privacy and the lack of security there. Imagine if your data goes to all the system on that segment. You don't want that, right? You don't want that to be broadcasting to everybody. And then to all the systems that are connected to all ports. So you have more security. You also have more reliability with the switch. Okay. So in the case that if we're using a hub, it's going to take up more bandwidth if you're sending a lot of data because, so let's say that I connect these 4 systems with the hub, it's going to send it to all 4, right? If I send a big chunk of data, it's going to send it to all 4, right? That will take up a lot of my bandwidth. So a switch would know exactly which destination that it's sent. If I send from the first system to the last system, it's only going to do so instead of sending it to everybody else. So you want to make sure that you have port security and also reduce bandwidth, which gives you more performance ultimately. Okay, so now you know, right? Always use a switch. A hub, if you have to use it, just know the disadvantage of a hub, the lack of security, and how it uses the bandwidth on the network. So traditionally, the old network, this is what we face, right, with the hub issues. Okay, so let's talk about virtual local area network. So as we learn in the layer, right, layer 3 is for network, which is routing. And then layer 4 is for transport. So what you see is that if we're using a switch that is layer 4, 5, or even 7, it's able to route and do all the other functionalities. So if we have a layer 4 switch, we can create what's called a VLAN. Okay. Some earlier model of some switches, right? You can't have one physical VLAN, but the reason why we create VLAN is we can have an isolation within the network. right? For example, I can have a network within a network, and I can do that for privacy reason, access reason, etc. Okay? So virtual LAN can be used mostly for security or to be able to do administration in an easier way. And we can do this to kind of reduce traffic and or to across many switches, right? Which ultimately use up a lot of the bandwidth. So VLAN is a way that we can take a group of ports. So let's say that your switch have 24 ports, and I can take 10 of those ports to set up a separate VLAN. Okay. And that allows me to use those ports for things like specific servers, specific departments, but ultimately it has to route to it, right? So your switch acts as a router. It takes the internal, instead of switching and transmitting back and forth, it needs to be able to route to that virtual network, even though it's on the same system, right? So let's say that we take the beginning port 1 through 10, and we're gonna be able to do this down the line. We're gonna set it up as a separate network where the rest is still on that same segment. So we can use different IP address to route to it, but ultimately we want to be able to control the traffic and how to minimize to not let it cross multiple switches. Only that one switch. Okay, so we're gonna revisit some of this concept down the line. Virtual LAN, you can find it on page 8, going into 9. We're gonna talk about VLAN. So it talks about how when it comes to that particular switch, right? It's going to reach a certain port that you would set up as VLAN, and it's going to set specific traffic. So it's kind of like this. In your neighborhood, there might be like 10 streets that belong to your neighborhood. Let's say that they block off one street and it becomes like a private street, but no one can go to it, right? The only way that you can go to it is maybe like having somebody escort you in. So VLAN is kind of like that. It's still in that same neighborhood. It's still on the same appliance, but what we can do is we can treat it as a separate area. Okay. Okay. Make sure we read through this down the line, and then for the managed switch, I'm going to quickly go through some of the protocols. We're going to come back to some of these protocols again when we do the VLAN. We have a whole chapter that dedicates to switches and VLAN. So you are going to see this on multiple certifications, specifically for Network Plus. They like to ask questions about VLANs and also the protocol. So the first protocol that you see is your STP. This allows you to prevent loops in the network because loop consumes network bandwidth, and it can also cause disruption in the network. STP basically look at all the ports that would have the loops that use for, and then it will block it. Okay, it's called the spanning tree protocol. And if the loop is broken, then the network is more stable. Well, switches are built with loops. It allows it to really check itself, most part. However, if we have loops, it would cause disruption. Basically, sometimes that can cause your switch to malfunction. So when you configure the switch, this option allows you to prevent loops from happening. So like I said, protocol is always tied to a service, a functionality of your device, right? So if you configure spanning tree protocol, that would prevent your loops from happening. Now, out of the box, if you just open it, plug it in, and use it, right? If it's not configured, then you might run into the problem. So if you're using a managed switch, you have to go in and configure a specific service for your switch. Then when you're dealing with VLAN, sometimes you would see trunking. And trunking is more of like an older technology, I believe. I think a lot of the switches now kind of move away from this, but um when we do packet tracer, you're gonna see some of this too. So trunking allows you to connect the switches together. And I think when we say connect the switches together is to configure the switches to be connected. Okay? And basically we can take one port and we would trunk it. Remember how we talked about the hub connecting to another hub on a physical port? Well, we can connect the switches logically by trunking, let's say port 1 on switch A to port 24 on switch B. Okay? What we can do is we can use it to carry the VLAN traffic on those switches that we're connecting. So it's, you know how I talk about that private road, right? That private road would have to have a certain exit, a certain entrance. Well, those are the ports that we trunk, right? That's going to be private for that virtual local area network only, right? So we would set up an actual physical port that we would trunk, and that allows us to set up VLAN traffic and connection for our switches. And you can find this on the notes. Okay. ISL and 802.1Q. This is known as inter-switch link for ISL, and this is specifically for Cisco technology. Okay. Now, as you know, there are many companies that create switches these days, not just Cisco. So, but once the majority that you see, right, they might use Cisco product. So if you're looking at ISL that's specifically for Cisco, this is used for tagging packets that are associated with the VLAN. Remember when I talked about VLAN as like the private road, right? And that private road we go back to trunking. Well, the people who travel down that private road is then specifically identified, right? That's how we label the data that goes down. So that means that when I'm using a virtual local area network, my traffic is specific. It is brought into that switch and passed down to another switch in a specific port, a certain path. And it would also be labeled, all my data, all my packets, my network traffic is then labeled for that specific VLAN. Okay. It cannot just go, oh, okay, this VLAN is not. How does it distinguish that? Is through the protocol force, but that's if you use the switches, right? So ISL is for Cisco technology. Now, all the other brand that is not Cisco, they use 802.1Q, which is the technology that is used for tagging method. So if you buy a different brand switch, they will not use ISL, they would use 802.1Q. Okay. And again, we're going to come back to some of this down the line. This is kind of like an introduction to it. Port mirroring. So port mirroring is a way that we can take a port, a physical port, which is a point of connection where you plug in your cable, right? And we can duplicate that, right? We can duplicate that same thing. We can mirror it so that way it would send it to the copy of your data in another port. Port mirroring is important in cybersecurity because we do this for monitoring purposes. So for example, I know that my server is connected to port 4 on the switch. Okay. I wanted to see what data is being sent to my server and how my server responds. So I'm going to take port 4 and I'm going to mirror that to port 10. Okay. So whatever that's passing through port 4 is exactly duplicate on port 10. We're going to use port 10 to mirror so that way we don't intervene with the actual traffic you see. Okay. So it's gonna have the duplicate data packet information, all the traffic that comes through. It's kind of like how they tell you to travel down one road, right? But there's another parallel road that's exactly the same. So if you travel down road A, it's the same as you travel down road B. But we are able to see that same information on the second point. Okay? And that's important in security because if you monitor, a lot of time you have to screen and that can slow down the traffic. You don't want that. So you do port mirroring kind of thing. And then E, so these are the features that you can integrate, the services and the features you can build, you can configure in the switch, basically. These are the things that we go over. Port security and authentication, you want to be able to, like we mentioned, right? Port filter, we can block, we can allow certain ports that can connect physically. Because someone can walk by and plug their cable into your switch. If your switch is exposed, most of the time we don't, we put it behind, certain things. So in this room, you don't see a switch, right? But in the case that if your switch is in the wide open, someone can plug in a cable. If you don't monitor your port security, then they can use your network basically. Okay, so it would allow you to only permit certain address, the physical address of that system. So if this happens, I cannot plug my cable in and be able to connect to the network, right? So we can manage who can connect by the MAC address. So we call that MAC filter. And let's move this down a little bit. Sorry. I know some of you are recording. I know it's lengthy, but you don't have to put verbatim. And then for port security, we can disable a certain port too, right? I can turn off a certain port. So in the case that if someone try to connect to it, it won't connect. I can also authenticate. So that means that even if they connect, they need to verify that it is allowed, right? So we can increase the security that way. So from a network security standpoint, this is some of the basic things that you need to do. But understanding this from a network technician or administrator, right? These are the things that you have to configure to accommodate the security services and, functionality and the health of your network ultimately. Okay, so we talked a lot about the switch and its capability. Now we're going to veer into the router. So the routers are a transit system. That's like the freeway that takes you from town to town, right? So the router takes us from one network to the next network. And like switch technology, it also stores the connected system on the table. Okay. Dynamic routing, basically, we would use the router that would pick up whoever that's trying to connect to it to be able to pass, right? So let's say that if I need to go from here to Corona, I would take the 21591 freeway to get there, right? That will be the router that I would use. Now I can also take the road, right? But who wants to do that? Or I can take a different highway. So there are many routers that we use to get from where we are to Google or to Microsoft or to whichever domain that we're trying to connect. Now, through the connection, the router retains its connection by having a routing table. This is in RAM. Okay. This used to store your route information so that way it can determine, right, where you're trying to go. Okay. Now, can someone modify the routing table? Sure, right? You can also specify the route that you want to be static. It's the same every time. Like it's like how I tell you to take a certain freeway, exactly the same every time you go from this town to another town, right? we can do a static route, or we can let the router determine which is the best way, like turning on Google Maps and saying, how can I get from here to Corona the fastest, right? So some router would do dynamic routing in how it handles traffic. Some router would have manually specify route as static route to go from place to transfer from place from one network to the next. Okay, so when you see the dynamic route and static route, well, sometimes you want your data to be private, secure, and you want to have the same system handling it, so you can specify static route. But sometimes you want fast response in interconnecting the networks, then you want dynamic route. So the routing store that information and it would determine, and we'll come back to how it's going to be able to do that, right? Okay. So on the notes, after you get through some of these, right, it goes into the router and multi-layer switch. It talks about that. So router only handles for WAN, where switch handles traffic for LAN, right? LAN. And it is routing, so we use network layer. Okay, so you can go through and read some information there. Okay, so let's talk about functionality of multi-layer switch, like what I mentioned. So when you buy a switch, a managed switch, likely that you're gonna have layer 4 switch or layer 5 switch. That means that it's able to route and transport with layer 4, right? If it's layer 5, then it's able to route, transport, and so all the added layer that you have allows you to have more functionality in the switch. So it would, instead of having a router and a switch, you can have a layer 4 switch. So in most data centers, you're going to see that they're going to use layer 4 or higher multi-layer switch to handle voice over IP, because your phone call to the data center needs to be routed to, right, the section of the department that's going to handle your call. For example, like I call to complain about my bill, right? That will be a group of people that handles that. But when you call to reset your password for your account online, that's a separate department, right? So what they do is they set up the layer 4 or higher layer switch, and they would create, right, segregation in these departments, so that way they can handle specific call. You know how you press 1 to go to pay your bill, right? And it will take you here, and you press 5 to complain to customer service, or press 0, right? It actually routed to the area of the data center, and it could be multiple data center that handles your call, not just one, right? So you would see the multi-layer switch that would do that. It would filter and route to the area of the network that you want. Okay. So whenever you have VoIP, that has to be layer 4 and up. Okay. Voice over IP. Okay. 17, what type of network devices would can be used to control collision in the domain? Your switch, and it would send the data to the port that the destination system resides, which prevents collision. Okay. And we talked about, in technology, how we talked about CDMA, right, before. So collision avoidance or collision detections. So what you see is you would see that a lot of the switches would have to handle the collision by detecting, right, a certain area of the network that it can send to, so that way it would prevent collision. It's kind of like, if there's accident on the first street, then I would avoid that by going on the second street. And the switch does that. It looks at the port that is very busy, right? And that can be having likely that there's high potential that there's collision of data or traffic. Then what you see is you would see that it's going to go to the frame and look at the destination system, and it's going to send to that. And then the network devices that are used to create broadcast domains, that's going to be your router or a multi-layer switch. And as long as it has the VLAN capability on the switch, it's able to do that. So broadcast domains that it has to reach, right? External domains. So that means that it has to also route. So you have to have a higher layer switch to be able to. Okay, so earlier we looked at the topology and I told you if you put a server at your router, I'm just going to assume that it is a gateway. So a gateway is a system that brings your traffic into a network and outbound, right? Inbound or outbound. A gate. So think of a gate, right? Like when you leave your mansion, you have to go through the gate. So a gateway system it can be a regular server system or usually it is a router, right? So a gateway, the purpose of a gateway is to ensure, right, the network environment can be accessed in another environment by translating information from one format to another. Remember that one network is different than the next. So the gateway, that system, its job is to make sure that the information is understood from one network to the next. Now, your router, your wireless router at home does this. Okay. That's how you're able to interconnect with your service provider and the rest of the world, right? So now, if we don't use a router, our system that we use have to be configured as a gateway. So it basically take one format and convert it or translate it to so that way one network can understand the next network. From like traffic to, all of those things. So now when you go through the configuration today, right? When you see these things, these settings pop up, you have to think about, oh, what's a gateway, right? What do I put here, right? So your router tends to be the default gateway. It doesn't have to, right? But most of the time by default, it is the router. Okay. I keep putting S on here. Must be I was sleepy or something. Okay, 20. The administrator wants to use a network device to monitor network traffic for suspicious behavior, right? What network device do they use? Well, you can monitor on your router and your switches. You can use Network Sniffer as a software to be able to use. Some appliances come with it, but they're asking for a device, an appliance, right? So a security system that we can use is intrusion detection system. This is an alarm system. It's only used to detect, right? Anybody that's strange, that's not part of the network, like remember what I mentioned, right? Looking at the map. So it basically check all your network appliances if you connect them to the IDS, and it functions as an alarm system. So it will sound off when it detects something irregular, right? Or out of its security scope. Now, detection system is okay. You usually put that internally in your network segment. Remember what I said earlier? You can connect that to a switch, especially for where your servers are sitting, right? Like your authentication servers, your important servers. Mostly because you want to be able to see if someone gets there. Now, detecting is after the fact, right? In security, we want to be proactive, not reactive, because reactive is too late. Okay. So IDS is okay, IPS is better, right? Intrusion prevention system is better. But to monitor, we can just buy an IDS. Okay. Now, when you read the note, it's going to tell you there's two kinds, passive and active IDS. Just like active and passive switch or hub, right? So an active IDS will monitor, record any irregular activity, and take some corrective action, similar to an IPS, similar to an intrusion prevention system. It might not be as extensive as an IPS, but it does have that same functionality. A passive system, it just sounds off the alarm. It doesn't do anything else. Okay. You know how some buildings have the fire extinguisher and the alarm? It would ring the bell and it turn on the sprinkler, right? So that's an active IDS. It turns on the alarm and it puts out the fire. Okay. If you configure it properly. Now, a passive IDS, it just turns on the bell, but it doesn't put out the fire. That's the true difference. Okay? Any question? So we need to know these things for Network Plus and Security Plus. Okay, I'll move 20 down. Okay. Real quick, I know I need to reserve time for your lab. I want to make sure that you get through it, and hopefully we'll have an hour or so. So it talks about broadcast domain. We touch on that here. Gateways, we go through that. So go through and read through. I didn't talk about firewall, right? This is going to come up in security class if you're in the security program. So firewall can be a software, can be a hardware. It basically is a filtering system, so you can use it to prevent or deny. If you ever been to San Diego and try to go to Mexico, right? You go through border. It's like a border patrol. It checks to see if, they usually look to see if you have the right paperwork, right? So the firewall checks to see if you have the right state. It could be, or status, or, IP. It could be different types of firewall within. And then your IDS information is following that on page 13. And then it talks about host base. So whenever you see host base, that's ran from a system like a server. Usually that's a software. And then network-based IDS. So earlier I gave you the example from IDS. From my standpoint, the best IDS should be the network IDS. It would look at all your network connectivity versus, system to system. So host base is system. Okay. And then it touched a little bit on the IPS, as we mentioned that the active one is parallel to that. And your wireless access point, I think we're familiar with that. That's different than your wireless router, okay? Your router is able to route. Some access point does not route. It functions like a repeater or an extender. And then you have the wireless extender that's just going to extend the signal. Voice over IP, this is used for your phone connection, but it uses IP address and TCP to be able to get your phone calls and your communication established. Analog modem, I think this is only used if you're using analog line, which is the old phone line. So you might see that. It looks similar to an Ethernet adapter if you're looking at the adapter, but it uses the RJ11, the smaller connector and the thinner line. Okay. Make sure we know CSU and DSU. This is probably going to come up on your certification. So your channel service unit and your data service unit, this allows you to have very high-speed internet connection. Back in the day, right? I installed quite a few of the tier. So you have different tier like T1 and T3, and we'll come back to some of the specific rates for these. And then I also installed quite a bit of ISDN. So integrated service digital network, this is old technology. Now, some company, they still keep this as a backup line. This was very expensive, and it still is if you're using it because of supply and demand. It is, you basically pay by data rate. And so there's very slow connection. So you have your BRI, it is 128 kilobit per second. and then your PRI is at 1.55 megabit per second. Remember that people were on dial-up at half of the BRI rate, 56 kilobit per second to start. Later on, when they start to have like DSL modem, it started there and it was climbing up a little bit. And then cable came, so that was close to 10 megabit per second at max. But as you can see, basically it's able to give you double of the dial-up is because it's able to couple up the channel, so that way you have higher throughput, but it still was using the analog baseline. Okay. So 22. Compare, contrast BRI and PRI ISDN connection. So BRI stands for basic rate interface. Just know that it is slower, right? So the throughput is 128 kilobit per second. That was the rate for connection. It uses 2 of the 64 kilobit per second per channel. So if I take 64, multiply it by 2, I would have 128, right? So when you're looking at BRI and PRI, always keep in mind that it is multiplier of 64 kilobit per second. So the BRI, we double 64 kilobit per second at the B channel. And one of the channel is 16 kilobit per second. This is only used for control, and that's called the B channel. So when you set up these connection, you have to configure the B and the D channel. One for control, and the other one is for data throughput. Then your PRI, your primary rate interface, this is going to give you higher, right? Much higher than the BRI at 1.5 megabit per second. So what it did was it is 20 multiplier. So you're going to take 20, or I'm sorry, 23 and multiply it by 64. So 23 times 64, it's going to give you roughly 1.55 rounded, right? So at the B channel, you're gonna set up 23, right? And for the D channel, there's only one at 64 kilobit per second, and D channel is only for signaling and control. So PRI times 23, BRI, the basic rate, times 2, 64 times 2. Okay, I'm gonna move this. Oh, actually, let's move the other one up. Okay. So you can refer to that section of the notes to kind of read a little bit more. I think it goes a little bit deeper with the comparison. Let's talk about load balancer in the network. And I think a lot of the employers, they like to ask you about this, but also when you're looking for network jobs. And part of cybersecurity, the A stands for availability, and our responsibility is to make sure that our network is always available, and we will have to refer to quality of service and load balancer. Okay. So the load balancer is an appliance, a system, sometimes integrated within another appliance, but it's a system that allows you to split the workload, right? Or the request of an application or servers across. So basically, it's like if I give you a very large job to do, right? The load balancer has a team of people and it's able to delegate that, right, across. So it's able to determine, right? Is it a large workload that it's handling, a large request, or is it a feasible request, a small request, right? If it's a large request, it's going to divert that to different part of the network so that way that large request can be handled quickly. It's like having a team to tackle that task quickly, right? Whereas if I don't have a load balancer, it might take me 5 hours to complete the job. Whereas if I have a load balancer, it might take me 5 minutes. Understand? So you reduce the amount of time because you are able to handle the performance and the throughput quickly, right? Load balancer is only effective if your network design work is built with load balancer in mind. Okay? Because if you have a very poor design in the network, even if you load balance, let's say that if I only have one way to pass everybody through, then that's the only way, right? It will take me 5 hours. The load balancer, I might have to integrate many ways to be able to pass the traffic back and forth. Okay? Now, if you're accommodating web servers, large enterprise authentications, application, remote access, you need load balancer. So if you have high traffic type of network, right? If you think about Amazon, definitely, right? You think about even retail companies that span across the nation, like Walmart, definitely, right? So, and you have prime time too, and your load balancer needs to kick in. Like prime time is when it's most busy, right? You ever look at like a location where it tells you they have the most customer here at this time? Yeah, so network administrator, they look at like the prime time for the performance. You might have a peak where a lot of people are accessing the network, usually operational hour first. Everybody checks their email when they come in, everybody downloads stuff, everybody uses application at a certain time. So we need load balancer, okay? All right. Okay, so load balancer, find that on page 15, right? You might have an actual devices for encryption. Usually now we use software for it, and then it talks about proxy. So let's clarify proxy once and for all, so that way when you take future classes, when they talk about reverse proxy, you know what they mean, right? A proxy server is a device that basically handles, it's a device in between, right? Your network and the domain, the internet request where it's gonna be, right? So for example, I can use a proxy as a police, like a traffic police, to be able to regulate which domain my user can connect to. You see this a lot in high school and middle school and elementary school. You know how the kids cannot go to some web pages, right? We can set up a proxy to be able to filter that. To implement the parental control or to regulate how they can connect. So basically it looks at all the requests that is sent through it. So you have to basically, your router has to get to the proxy, right? Or it has to go from the proxy before it reaches the router, right? So that server is going to look at all the requests. It could be, you need to have many proxies, you cannot just have one. Because if you have one, then you're gonna have slow traffic performance. And it's gonna look at all the websites that are requesting and then check that to determine and record it to determine if it's allowed or not, right? And we can use a proxy to boost performance, not just to block people, right? From a security standpoint, that's like an easy example for me. But I can have thousands of proxies, right? One proxy is going to handle all my, maybe 10 proxies is going to handle all my web server requests, right? So it's going to look at like who's requesting, where that's coming in, how, to be able to manage that. Let's say another 100 proxies is going to handle all my user application that is tied to web. Like let's say that finance department use a lot of application that is connecting via the website, so web application and so on. So now the important part is, in security, we go back and we look at the logs. However, it really look at the service and the protocols. So it's just like a middle system that is inspecting and diverting the traffic. So proxy usually tend to go with the other system that we just talked about, which is your load balancing. Okay. Getting there. Okay. Any question regarding some of these? I know the terminology is new. We talked about different system role. In these technical classes, you have to be familiarized with them over time, right? It's important that you do because this is what the industry is made of, right? This is what we use. So this might be the introduction, but over time, you're going to use it repeatedly and it's going to get easier to remember. Okay, the next few things we're going to talk about is your cloud technology. Actually, no, I'm sorry, virtualization. So how often do we use virtual machine? We're going to start today in this class, right? We use virtual machine quite a bit, more than you know, right? So whenever that you see a company using cloud or cloud servers, that's basically a remote server that's located in someone else's property, like AWS, and I rent it, okay? And I would pull up my virtual machine through it so that way I can run my infrastructure, my operation, like my mail, my authentication, so my student can log in, like RCCB uses that, right? They use I think they use Hyper-V and along with VMware. But anyway, so virtualization is a way that there are multiple types, right? It's a way that we can capitalize on maximize our hardware capability using software or using resources. Because it cuts costs and it's beautiful. So today you are going to use a certain virtualization technology, right? So let's go through them real quick so that way you know. Okay, read through these, right? I know that so packet shaper is important. You can use it to shape your packets when it routes so that way you can increase your bandwidth. And then VPN, virtual private network. I'm sure a lot of you know what VPN does, right? It keeps your connection private, but you can create what's called a concentrator or use a system for that, right? And it allows you to have encrypted connection and that allows you to have remote access securely. You can also have VPN servers along with the concentrator for this. Okay. And then if you have multiple access point, it's good that you have a controller. And here it goes over some of the terminology. So make sure we go through them because I probably won't have time to go through everything. But virtualization, a virtual machine is a way that we can use RAM and storage. It doesn't have to be a hard disk. It could be solid state drive, right? To be able to simulate, right? Or install an actual server, a physical server using the technology that we have, hardware and software. Okay. So some of the products that you would see in the market commonly is going to be VMware, which uses, we're not going to use VMware, but VMware is the common product. The server itself is called vSphere, right? The Microsoft version of this, they use Hyper-V. There's heavy concentration in the certification for this. And we mostly create virtual machines for server components. Okay. So your hypervisor, there are two types. There's type 1 and there's type 2. Type 1 uses software directly on top of the hardware, and then it has a host operating system running a parent virtual machine. So you're using hypervisor type 1 today. Okay. So basically you have a regular system that already have OS. It needs to have the software, which is your virtual box today. And you're going to run your virtual machine on, either your desktop, you're going to transfer that. You can also run it on the external hard drive. Okay. Now, type 2, you need to install the OS on top of the hardware, right? Then installing the virtualization and create the virtual machine. I'm sorry, we're using type 2 today. And type 1 is what you see commonly with a lot of the cloud technology. So what we do is you have to have an actual OS, and then you have to have the software, which is your virtual box. On the other one, you can just run it directly on the hardware itself without the OS, right? You see this with thin client, and I gave you some example, like your server, you have to acquire this particular software version of the server to be able to use that. Okay. So let's answer some questions. Okay, so 25. Type 1 uses software that runs directly on top of the hardware, and we would use this with Hyper-V. Okay, this is Hyper-V is a version type 1 for the virtualization. So then the host operating system runs the parent virtual machine. So you have to install a Hyper-V license, and that allows you to access the hypervisor to be able to access the hardware of your host system. So let's say that you are here and you're trying to connect to Azure or Microsoft owned cloud, right? Basically, you have to have Hyper-V installed on your system in order to connect to your instances at Microsoft server. Now, if you're using the type 2 virtualization technology, you can just run your regular Windows OS, right? And then you would virtualize it with installing and creating the virtual machine that we would have other servers. So you're gonna see some of that down the line. I'm gonna have you use a virtual machine that I made for server, and you're gonna configure it. So we mostly use type 2. For 26, what type of cloud deliver models that would consist of multiple companies sharing costs in the cloud service? So you do see that they have what's called community cloud, where if I can't afford the cloud because of cost, I would be able to share that with another company, and so that's called community cloud. When implementing cloud, what should a company consider? Most importantly, internet connection. So if you lose internet connection, you cannot connect to other networks, right? So internet connection just represents that we can connect to external network. So your connection to external network is important. We need to think about security policy based on regulations for local and where that cloud and storage and services. And you see TikTok is dealing with that now, right? Because at the beginning, the majority of the data for TikTok was housed in China. And now, because of the regulation that's implemented for America version of TikTok, they now start to house a lot of things outside of China. But where that geographic location is, they can require how you maintain your data, how private is your data, how secure is your data. So if you're housing your data in the United States compared to China, sometimes could be more or less restricted based on the regulation, right? So that you need to think about when you are buying cloud or leasing cloud. Okay. I know the first week we talk about fiber. For fiber channel, so for 28, identify and describe the type of network storage connections. Fiber channel would be the connection using what's SAN, and we would implement SAN for network storage purposes, right? Would involve buying equipment with the fiber channel switches, so you have to get the switch that accommodate fiber channel. And then you need to make sure that you have the cable so you can connect it. So you have to have the appropriate cable for that switch. and which is why it is costly to implement SAN. You don't have to write everything here, but basically it uses FCP to transport SCSI command, and when you see FCSI, that's just acronym, and we call that SCSI to be able to carry it over the fiber network. Okay, so that's one. And so where do I find this information on my notes if you download it, right? If you go down past the virtualization and go through, please read through this. It gives you different types. Like you can have virtual routers, firewall, desktops, servers, etc. And then cloud computing. So here it talks about SAN, right? And it talks about network attached storage. They're two different things. And you say, oh, they're just reversed, right? No, because the connectivity in the systems are slightly different. So network attached storage allows you to add more storage to maybe your server to be able to have a file server, where storage area network allows you to have a group of storage devices that would be connected to other devices like your servers for data. And they tend to be more. So for storage connection type for SAN, we would use fiber. And then it talks about iSCSI. That would be for SCSI type of technology. So, and that's kind of older. But if you do see legacy technology that uses iSCSI, you would see that, and you would have to have appropriate software. And then FCOE, it talks about that for iSCSI and InfiniBand. So go through and read through that. So for iSCSI, and you can grab that from the notes itself, right? And I broke down a little bit. So for the fiber channel FCOE, this allows you to encapsulate the frames for the fiber. So we need to convert fiber communication to Ethernet, and this technology allows you to do that. Okay. Because not all part of your network are fiber. Most of your network is Ethernet, right? And so when it goes from fiber to Ethernet, you need to have this. And then your InfiniBand, this is a newer standard that would be integrated with fiber channel and Ethernet. And this is just a way that we can also connect high-speed communication systems, and we would interconnect them. Okay, 29 talks about jumbo frame. So a jumbo frame, it would be used to reduce large data overhead. So if you are streaming, if you are a gaming company, likely that you're gonna have a lot of data that's overhead. So you have a lot of data and connection. Now they're talking about like AI and hosting that, right? So when you're sending, jumbo frame allows you to send larger byte size compared to normal frames. So sending one frame for 9,000 bytes instead of 6 frames, right? So it's able to chunk it up larger, so that way, because frame really represents like your data header, right? It contains that. And so in the case, the maximum can go up to 1,500 bytes. Remember, we talked about flow control. We really regulate like what's the size of data going into each frame, how many frames that would be sent through the network, right? So if you are dealing with the larger data size, to handle that, we would use the jumbo frame, which allows us to send more bytes in increments over time, right? So if you are a company that handles a lot of media, like I said, right? Large files like video, audio, stuff like that, you will need it. Okay. And then 30 for industrial system. I know some of you would be hearing this again in 27 in another class. But industrial system that control and monitor manage equipment such as production plant, air conditioning, systems across like the span. So if you're looking at a manufacturing company, they have a lot of different area like production floor. If you're looking at warehouses, then you have shipping and things like that. So there's a system that control other systems, even the thermostat, right? The lighting. You know how the street lights come on at a certain time, right? They program these controller to turn on your lights, stuff like that. So these are called SCADA. There's a downfall in them, right? If you think about like industrial security and things like that. So a lot of times you see that people will try to get to these controllers to shut down like your plant or whatever. So SCADA technology is important to push updates and so on. But a lot of the time they're older technology too. 31. The system that consists, I know it's so long, it's just because there's so much concept for Network Plus. The system consists of network that has been optimized for voice, video, web pages, and other form to give you rich media experience is also labeled as media nets, right? Media nets. And we talked about the protocol and the service last week, but they're also be referred to as you have systems that would handle your rich media. That would be media nets. And for the type of cable that we use, you often would see plenum grade cable, which is higher in price. You would use this between floor and ceiling. So when they're running cable, you see this is a fault ceiling. There's a ceiling above that, right? So in between the fault ceiling and your real ceiling is where all your cable to your switches and all of that goes. We want to use a certain grade cable so that way it doesn't catch fire when it's too hot, right? In case of fire breakout, it doesn't, cause any additional fire or damages. So we want to use a certain type of cable, but for platinum grade, we want to make sure that, why should you use it? To make sure that we avoid toxin and also, the release from the polyvinyl, which is at the coat of your cable. And that can also have toxin that would create like, or it would induce fire, okay. But they're pretty good at making, media that is fire retardant, right? So we want to use platinum cable between your floor. So in the data center, you're gonna have a fault floor and an actual physical floor, and then run these cables through that way. The same thing with the seat. 33, which is used to connect patch panel. They already actually wheeled out on my patch panel, but the patch panel allows you to distribute the actual copper wire to your rack, right? And it would be used to connect MDF and IDF. So you would use horizontal cross connect cable, which is known as HCC. And it's used to connect the patch panel. I will try to bring in a patch panel next time you come. I had it in here and they had wheeled it out because it was taking up so much room. And then you would use the VCC to connect the MDF and the IDF. So this is actually the one that's answered the second question here. So you would use HCC, the horizontal, to connect to the patch panel, right? The cable to the patch panel. And then the VCC would connect that to the rest. So your MDS and IDS. And then last question, you want to label your cable, right? You want to label your system so that way it's easier for you to troubleshoot. And we want to label port, system, circuit, and patch panel. Okay, however you want to use your label. Normally, having organization in technical world is helpful. And use color coding. Okay, so one segment will be red, one segment will be blue. This segment we're sitting in is yellow, as you can see the yellow cable is used. So we want to label. Okay, you can use a label maker and wrap it around your cable. You can also label your port and keep inventory of it. Any question? Okay. Let me stop.